Today on the Chaos Dubs channel, I'm going to teach you how to build a custom bass bin in any size of speaker specific to your needs. This is part 1, designing your custom sub box from scratch in less than 10 minutes. Let's get right into it. Once you've decided that you're going to build your own speaker, there's a few basic things that you have to know. So we're going to start with the theory. Speaker Building 101. First of all, human hearing rolls off completely at about 20 hertz. Some humans can hear as low as 18 hertz. And secondly is when you get a frequency tuning on a subwoofer, it's going to give you a 6 decibel boost right at the peak of the tuning frequency. So you're going to get, roughly 3 decibels of a curve on each side of the tuning frequency that you have. For a much more simple representation, imagine that the orange vertical line is the frequency that you've tuned your speaker to, and the red line is the gain boost from 0 to +6. You'll see on each side from the bottom of the orange line to the red line would be about 3 decibels worth of gain boost. That being said, you don't want to go too much lower than 28 or 30, simply because you still want to retain that lower end boost. And essentially what you're going to get out of tuning your subwoofer is free power from your amp, or perceivably free power from your amp. That 6 decibel boost doesn't cost any extra electricity draw or amp power to produce. It's simply because of the design of the box. The next couple of choices that you have are going to be based on the type of music you listen to and the type of space that you have. So first of all, you're going to want to decide what speaker size you want. If you listen to a lot of low heavy music, the bigger speaker that you can put in there, the better it's going to be in the end. You're also going to want to decide on the design of your box. There's several different designs. We're going to talk a little bit about that later on in the video. And for simplicity's sake, this video is not going to cover any advanced boxes, any bandpass stuff, anything like that. It's going to be really basic ported boxes that are going to sound awesome. My suggestion would be to make the box as big as you can dimension-wise for your space, and then also to have it tuned as low as you possibly can. This is where a handy little free program called Speaker Box Tuning Calculator is going to come in really handy. I'm going to leave a link in the description as well, as it's on the screen right now. Once you download and launch the program, it's going to look something like this. And simply, you just want to enter your dimensions, so height, width, and depth. In this case, we're going to go 18 by 18 by 10, which should be roughly okay for a 12-inch subwoofer, say for like a car box. Now your port dimensions. So you can have 1 port, you can have 2 ports, you can have 4 ports. You can also choose to have square, triangle, or round ports. It really doesn't matter as long as you retain these dimensions within your ports. So we're going to go a 6 by 8-inch port, and that is going to be 6 inches deep. Now as you see, it's starting to fill in all the numbers on the right hand side here. The important numbers you're going to want to look at are the tuning frequency, because this is essentially what you're shooting for, to be as low as possible. Here's your net volume of the box, and then up here is your cut sheet list. So it automatically tells you what sheets you need to cut, and it's really simple to get this done very quickly. There are a few extra things that you can do here if you do have this information, such as the woofer displacement, extra baffles, external ports if you have any, bracing displacement, and so on. And in this case, by dropping our port dimensions by a little bit, you'll see that we've cut our tuning frequency nearly in half. So before we move on to some more detailed stuff, let's just try to scale this up a little bit and see what it looks like. Let's go 24 high by 36 wide by, we'll go 24 deep. And now that's going to change things quite a bit. So let's check out the ports here. We're going to go 6 by 6 by about 18. So this width is a little wide for what I'm trying to do here. Try 30 instead. Anyway, so if you're going to use an 18-inch subwoofer, this is kind of more the dimensions you're going to be looking at. You want to get your hertz as low as possible, but to do it you're gonna have to balance the size versus the tuning frequency. So the lower that you tune it for a larger subwoofer, the larger your box is gonna be overall. So this is 7.79 cubic foot, and if we drop this to, 24, now you're gonna see it's 6.03 feet. So it's a lot easier to fit that than a larger box, but your tuning frequency also goes up. Now, I wouldn't try to go any lower than 21, simply because it's kind of pointless. Even anything lower than really like 28 or 30 is kind of pointless, simply because you get a 6 decibel boost with a curve on each side of the peak of where this is tuned. And once you get too low, you can't even hear the boost that you're getting on the lower end. Once you're happy with everything that's laid out here and everything fits within your parameters, you can go ahead and mark down the cut sheet list, or you can even print it at the bottom. And you're going to need to cut those out to do a regular square subwoofer. But if you want to do something a little bit different, a little bit more advanced, say a subwoofer with a slant on one side, that can also be done. All you have to do is go ahead and change the height number 2 and depth number 2, as well as the number of your ports if you would like. And that's going to give you like a second height. So you could go 20, for example, and the depth would be 18. So that'll give it a bit of a curve, right? And also, if you want to change your ports to round, instead of going height and width, you get rid of those. You go number of ports. Let's say you want to do 2 ports of a diameter of 5 inches and 18 inches long. It's going to give you also the measurements you need. Now, if you're in the market for building a more complicated speaker design, such as bandpass, loaded horns, or anything that's way up and above a simple square or rectangular box, there's another program that you can get for free, and it looks like this. It's called HornResp, HORNRESP, and I'm going to leave a link for that in the description as well. You'll notice when you mouse over on the bottom, it tells you what these segments are and exactly like the conical flare and everything you need to know to be able to build a loaded horn. There's also diaphragm area, like this is all your displacement and all this other kind of stuff. This is beyond my understanding, to be fair, but a little bit of research, watching some videos, and some dedication will get you a long way into building loaded horn speakers using this software here. And I want to give you a little bonus before we end off today's video. I'm not going to get too into depth about this, but I just want to put it on your radar if you're considering building speakers as something I think you should know. There's something called group delay, and this phenomena essentially changes the way that sound sounds when you're using large volume speakers such as this, because of the time that it takes for the air to move and actually come to hit your ears. So when people are listening to speakers on a PA rig at like a show, everything sounds different. It sounds better. It sounds, I don't know, more full. And when you listen to it on headphones, for example, or like a Bluetooth speaker, it really lacks a lot of the same sound, and it almost sounds completely different. Well, that's because group delay is involved. So group delay does kind of change the bass response a little bit, and when you hear things on a big system, you get used to it, and that's really what the sound is meant to sound like. Whereas on these smaller systems, you can't really emulate that. It's just not possible, so you won't really hear it. Personally, I find group delay really fascinating, and it's something that I find not a lot of people know about, but I feel like it's a critical piece of information if you're into bass music or if you're into, sound at all, really. Feel free to do some more research and get a more in-depth understanding of this stuff, because it's all going to help you in the long run. With that, I want to end off today's video. I want to thank you all for watching, and hey, I hope this helps you out. If you found it informative, entertaining, or useful, please leave me a like. If you disliked the video, straight up leave me a dislike. I can still see them. If you have any questions or you need some help, just leave me a comment in the comments, and I'll try to get back to you as soon as I can. And make sure you stay tuned for part 2, which will be coming out hopefully in the next couple weeks when I get it done, which is going to be putting the subwoofer together. With that, we'll catch you next time. I'm going to be trying to put out several videos per week and try to change things up a little bit, do a few different things. So stay tuned, take care, be grateful, and peace and love.